StarCraft was cool, Command and Conquer was cool, but in Age of Empires you could pick Bulgaria and Poland, which in my opinion was one of the greatest moments in gaming history, next to Ant Simulator. If you grew up in the early 2000s, you have played Age of Empires, and today you are suffering from back pain and are probably in debt. But in order to cope with reality, you are watching a C++ guy who sounds like he's gonna send his son.
Send him 2-3 years Dagestan and forget.
Today we're gonna take a look at openAGE, an open source game engine that can run Age of Empires on modern systems and allows you to make your own games. So after this video, I wanna see someone create Age of Balkan Wars. Let's bring the 90s back. Yugoslavia has entered the chat. We can simulate Bulgaria fighting Romania, Croatia having a peaceful disagreement with their best friend Serbia, and Bosnia, well, Bosnia doesn't need anyone, Bosnia can attack itself or step on a landmine. So first I will give you a project overview, then we're gonna take a look at the software architecture, the engine and concepts. Then I'm gonna walk through sections of the source code, and last but not least, I'm gonna explain how you, even as a beginner, can contribute to this project, so stay tuned. Okay, let's start at the official homepage of openAGE. On the first look, this reminds me of the Open Roller Coaster Tycoon page. openAGE is a cross-platform RTS engine providing Age of Empires style game mechanics. It is free as in freedom. You can use openAGE to run the original Age of Empires games, if you of course have the original game data. So if you're someone who always wanted to create their own RTS, this project might be a good starting point. Now if I click on the Get Involved link, it leads us to the GitHub repo. So let's scroll. Okay, this project has about 200 contributors and is mainly written in Python and C++, with the engine being written in C++, which is our main focus. Now, this project is so well documented, and if you want to learn anything about game development or generally speaking on how to create a great project, you can learn a lot from this. I mean, of course, there are a lot of people who expect someone to take them by the hand and walk them through everything like a babysitter, while doing all of it for free, and these people usually don't make it. And I'm not talking only about programming, that's a general observation that I've made over the years. Okay. And this section explains how to build it. And I have to admit, I wasn't able to build it on a MacBook Pro M3, maybe I made a mistake somewhere, but I didn't want to waste too much time on it since my only goal was to generate the CMake compile commands JSON for setting up Sourcetrail. However, Sourcetrail kept crashing whenever I tried to load the file, so I ended up configuring it manually. Okay, let's take a look at the documentation, read the docs, and now we can go to the project structure. Oh man, this is so true. One of the biggest problems for newcomers who want to contribute code to free software projects is that they have no idea where to start. If you ever come in the situation that you need to work on an undocumented code base, where you don't understand right away how it works, and someone tells you that it's a skill issue, you can be sure they have no clue what they're talking about. And trust me, it is much more dangerous thinking that you understand a big complex project than being real with yourself and admitting I'm not 100% sure how all of this works. Reading, understanding, and finding the relevant code part is hard. And after reviewing a bunch of code bases, I have to say that you need so much more time to review an undocumented code base compared to a documented one. Even if it's just a diagram and few sentences for each module, it helps enormously. So let's go back to the top. Okay, architecture is something we will take a look in a minute. Then we have languages, that's C++, Python, and Cython. And then we have the folder structure. Anyone who worked in a professional setting knows the value of a properly structured project. It might seem trivial and nonsensical spending too much time into the folder structure, but boy oh boy, if you do it poorly, you will have a hell of a job in case you need to restructure and refactor it later on. Few times at work I was sent to help out in a project and the structure was so unmaintainable that I ended up restructuring and refactoring everything. So in this case, it is in a way similar to the other projects I reviewed on this channel. We have the build stuff, we have assets, configurations, documentation, and then comes the part which we are most interested in. It's lib openAGE. This is where the engine resides. Okay, let's take a look at the architecture. Overall architecture. Before we continue, if you like the content, hit like and subscribe. Apparently only 2% of my viewers are actually subscribed to the channel. And I wanna say a big thank you to my Patreons and YouTube members. So if you wanna get your name on this list, the link is in the description. If anyone is wondering, I switched to light mode because the diagrams were not visible in dark mode. Okay, now let's go back. Okay, components, overview. Okay, so openAGE is separated into many modules, aka subsystems. Some of the components are already implemented, others are not. All of them need to be revisited to implement the goal architecture. And now we have the components and utilities. From an architecture point of view, these tools are oftentimes seen as in the same group. But if you ask me, I prefer it this way. So we have components and then we have utility services. For example, very common utility components are error handling, random number generator, file system, and logging, for example. Now, when we talk about the random number generator or RNG, it depends on what we are building. If it's a game, you don't necessarily need to generate true random. There is a difference between true and pseudo random. You can Google it. So if it's a safety critical system like a car brake system ECU, then on modern hardware, like for example the RX Tricore or something, you will have a HSM on the microcontroller, where you can then generate random for encryption purposes, for example. I don't want to go into too much details now. Let's take a look at this diagram. So this is the current architecture. So in this diagram, we can see three sections, which are the subsystems, okay? We have the presenter, we have time, and we have the simulation. Let's see if we have some documentation, okay. And it says it is largely decoupled from each other and communicate via defined interfaces. Now, this is again good practice to decouple the subsystems and only allow communication via specific interfaces. Sometimes when designing the communication between two subsystems, it makes sense to build in a facade component, which is then used to handle the communication. In automotive systems, which are using AutoSAR, and I don't want to dive too deep into the AutoSAR black hole today, you have the RTE, the real-time environment, which is used to handle the communication between application side and base software side. But from a high-level perspective, you could say it has similarities to the facade, okay? Now, if you take a look at this diagram and at the simulation subsystem, we see this simulation component. It is like a single component, but this does not mean that simulation is a single C++ file. It can be many files which are grouped in a module, in this simulation module. Okay, let's keep reading the documentation. openAGE does not have simulation steps or ticks. Okay, this is interesting. So if you remember my last video where I reviewed Luanti, the Minecraft clone, Luanti and also Quake, for example, they both use ticks. So in Luanti, you had this tick step update routine. And openAGE does not work with ticks. It is event-driven and scheduled by time. Okay. Decoupling allows us to treat some subsystems as optional, such as the render and input system. Basically everything from the presenter. This is in my opinion also best practice, so hard decoupling of subsystems gives you a lot of upsides. And let me elaborate on this for a moment. So first, it is much easier to develop and test each subsystem separately. If I clearly separate the responsibilities of each submodule, I can delegate the workload in a more structured way amongst my team members. We then just need to align on the interface between the two subsystems. Another benefit is testing. Let's say I could just take the presenter and create a mock of the simulation and test it against the mock. Now in this case we are developing a game, so we don't have that many boundary conditions, such as functional safety, for example. But imagine now we are developing an application with a functional safety aspect for a medical device that has an integrated battery. In that case, it is of crucial value to properly define your subsystems, to separate the functional safety components from the non-functional safety components. Why? There are many reasons, and I could go on and on for an hour, but let's put it this way. Functional safety relevant components have to be treated more strictly in terms of testing than non-functional safety relevant components. So if you have a subsystem where only one component is functional safety relevant, that will make in some cases the whole subsystem safety relevant. And then you would have to treat each component as a functional safety relevant component. Now if you take a look at this diagram again, they said this is the current architecture. And then we also have the goal architecture. And if you're not a prompt engineer, you will see that the goal diagram just includes two more subsystems or components, doesn't matter how we call it. This might look simple, but it follows another best practice when it comes to maintainability of software. We can even say it follows one of the solid principles, even though I'm no strict rules/principled fanboy. In this case, it follows the open-closed principle. Open for extension, but closed for modification. And you can already say, if they follow this diagram, there is a very low risk they will break the existing architecture by expanding the codebase for two more components. Whereas if they try to build in this networking and scripting somehow in here in one of these components, they would need to restructure everything, and the risk would be much higher that something will break along the way. So talking now from my experience, every time you try to integrate some new component into an existing working code base, something broke. But every time we tried to build it on top of the existing working code base, we didn't have that much issues. I'm not saying we didn't have any issues, but it was disproportionately lower, okay? Now, if you take a look again at the documentation, we will see that, okay, networking forwards are relevant events, blah, blah, blah. We will have a single authoritative server. Now, just like in the other games I reviewed, they want to use this authoritative game state on the server side, so the server dictates the game state to the clients. And then the new workflow would then look something like this. Okay, renderer, input, event system, simulation, renderer, output. Okay, so that is the general software architecture of the project. Now, for some components or utilities, you have a dedicated documentation. So for example, if for scientific reasons you are into curves like myself, you can read more about that here. Now let's dive into the software architecture of the engine. Okay, so this is the current state of the engine core modules. So we have the game state as the core module that handles the game mechanics, but you also have other modules like renderer, presenter, network, event system, and world updater. So let's go briefly through each module. Renderer receives game data like graphic assets and positional information from the game state and shows what's happening on the screen. Presenter, the local user input and output for everything that's not graphics. For example, it translates past keys to the game events. Then we have network, it handles the multiplayer network stuff. Then we have event system, manages and tracks events in the engine and ensures that they're properly ordered. The latter is important for receiving network events. And then we have the world updater, which applies events to the game world. Now, in order to keep the maintainability and flexibility high, they decided to minimize the dependencies between the components, which again is also best practice. This approach also allows easier low-level modding of the engine later on. Okay, what else do they say? On the other hand, we hope a loose coupling keeps the code maintainable and prevents the engine from evolving into a giant spaghetti monster. This is something that happens more often than you think. People start simple, then keep expanding, upgrading with the just code mentality. Before they know it, they summoned an unmanageable mess. Okay, then they start describing how the game state works. You have in-game units. Units have so-called abilities, which define what they can do, like move or attack, what they are they selectable or not, and what traits they have, attributes like hit points. Now, every ability has a corresponding gameplay system, which handles all the calculations to do the associated gameplay action. Let's take a look at this picture. You have to keep in mind that in real-time strategies, most gameplay mechanics can't be modeled as a single action. For example, when you want to attack with a unit, it will be a sequence of actions. The unit will move to the range and then start attacking, for example. Or in this example they provided, the gathering of resources mechanic is much more complex than the attacking mechanic. So the unit moves to the resources, gathers until its capacity is full, then goes back to the storage point, then unloads the resources, then goes back to gathering. Now, if you take a look at this diagram down here, we can see how all of this works in an event-driven setup. What do I mean by event-driven? So in this event-driven logic, in contrary to the time-driven or tick-driven logic, the units are not waiting for a specific time interval or tick interval. The units wait for the next event to happen and then proceed with the next action. The nice thing about this is you can integrate very complex behaviors, and you don't need to define the same mechanics over and over again for each unit. You can use the same attack mechanic for every military unit in the game. Okay, now let's take a look at entities. Now, entities in openAGE are very different than in the other engines. They have defined an API for handling the entities. Let's take a look at this diagram. Okay, here we go. So the API provides a flexible and reusable structure that lets developers create different units without modifying the game engine. It allows easy expansion and customization, making it ideal for modding. If anyone is interested in the details, there's like 15 chapters of documentation about their API, how it's handling the stuff and how to use it. But there's one more interesting diagram in here, and that's this one. Okay, so let me open the diagram, and here we go. So this is a monster diagram. But now if you take a look at this diagram, you will see that everything is pointing to entity. That means that everything is basically derived from entity in here. And they explain it as follows, I quote, "The whole API is part of a single object tree. All API objects inherit implicitly or explicitly from the root object entity. This will keep the hierarchy of objects consistent even if a lot of mods are activated at once. It also allows every object to be added to a set with type entity." Now, if anyone wants to understand how everything works in detail in here, I would suggest to read the documentation, take a look at this diagram, analyze it, and maybe try to make a mod. I mean, this is hands down one of the best documented projects that I've reviewed thus far. Okay, that's everything from the architecture overview, and this is of course a very short overview. In order to review the whole architecture of the project, every architectural concept, it would take me probably like 10 videos or something. And if anyone's interested in this, I will leave the links in the description. And I mean, if you have the time, if you're a student or something, or don't have any other hobbies, why not try make a mod for this game engine? You can make a World War III mod or something so we can prepare maybe for the upcoming events in the future. Okay, now let's take a look at selected code sections. So let's walk through this. The part we're interested in is lib openAGE. Now, what you would expect from the other engines written in C++ is a lot of inheritance chains and a lot of object-oriented programming paradigms. Well, there are elements of object-oriented programming here and there, but there is much less than in the other games that I've reviewed. Let's open Sourcetrail for a moment. Now, if you open Sourcetrail and search for example, game entity, we will see we have this game entity class. And now what you would expect is that game entity inherits from entity, but that doesn't happen in that way. In the other games, we had, for example, on top entity, and then all the other classes inherit from entity, and it builds this very long chain of inheritance. Now, in this game, I expected to have on top entity, then something like units inheriting from entity, and then specialized units inheriting from unit. But it's not structured that way, okay? Why? Because they are using the system of APIs and Nyan. Now, I haven't mentioned Nyan before. Let's open it. So Nyan is this type-safe hierarchical key-value database with inheritance and dynamic patching. And the developers have created it for this engine. I mean, this is huge, but let's go back to the source code. And now if you open the game state and then the API, you will see that all the ability, activity, and so on have an API that is used to evaluate the Nyan objects. For example, if we open activity, so activity has, for example, this API activity event that checks if a Nyan object is an event. So by doing it this way, you don't need to place the inheritance inside the code, which would remove the flexibility from the modding aspect. By doing everything with the Nyan objects, you don't need to adapt the engine if you want to add new units or something. The exception is, of course, if you want to modify low-level mechanics of the engine. But generally speaking, it is a very pleasant to read code, and in my opinion, the fact that it hasn't these long chains of inheritance makes it even more readable. So we can briefly take a look at, for example, this ability API, and you will see it has the same mechanics as, for example, activity. It has this API that then checks, for example, in this case, if a Nyan object is an ability, or you can check the properties of an Nyan object, and so on. And now if you go back to activity, you will see that everything is structured in a very similar way. Animation, yeah, it's basically structured in the same way. Okay, so I'm not gonna make a detailed code analysis, but they are using very good C++. I saw very clean code, templates, and yeah, generally speaking, very well documented code. And what I also like is that, for example, if you go into the engine files are not like 20,000 lines of code. Everything is very well structured, and you don't have these like 1 million inheritance chains, and you don't have files that are 50 million lines long. And that makes the code very, very readable. And if it's very readable, then it's easier to maintain it. If you're a beginner, I can only recommend you to clone this repo and just read the code. They use, as I said, templates, smart pointers, and there is no like raw dangling pointers everywhere and undocumented code. And that's also a reason why this is maintained for, I think, more than 10 years or something. Okay, now let's talk about how you can contribute to this project. If you go to the Git repo and then at the bottom somewhere, you will see contributing. You might ask yourself now, sounds cool, but how do I participate and get famous? And there's an important message in here. You don't need to be Terry Davis to become a contributor, okay? There are plenty of trivial, beginner-friendly issues that need fixing. Like, for example, my build problem. Do you know how many times I've tried to build something only to find out that some library update broke everything? And that is your chance to get involved. Now, fix the build, write documentation, or simply ask how you can help as a beginner. In this case, you can even chat with the developers. If you don't understand something, just ask. And trust me, if you ask politely, people will help you. Now, if you go to the contributing guide, here is like a full tutorial on how to contribute to the project. It is everything from how to find issues, how to properly do a pull request. They have even explained what's rebasing somewhere, yeah, here, what's rebasing. Then they also explain like how to change commits with amend and fix up, how to push the changes, and then at the bottom also some extra tutorials on rebasing and how to use Git properly. So if you're a beginner that wants to contribute to something, or not even a beginner, if you just want to contribute to some project, this is maybe something you can do in your free time. And as I said, if you're a beginner and want to know how the job really looks like in reality, I mean, if we cut out all the meetings and HR bullshit, this is a very, very healthy environment, okay? The industry is much more toxic, I can guarantee you that. I mean, there are also good examples, but I worked at some toxic environments and also at some great environments. So don't be afraid, go in here, check the issue tracker, maybe join the Discord. They don't have a Discord, they have Matrix, but join the chat, talk with people, ask questions, or just ask generally questions on how stuff works. I mean, people will help you if you just ask politely. This is not Stack Overflow. If you ask someone politely in here, I'm 99% sure someone will help you. And this is how you get practice. This is much better than tutorials. I mean, if you fix one issue in here and you become a contributor in this project, that's so much more valuable than doing just another C++ tutorial. Okay, so that's it for today. As you can see, I'm trying to improve the format of these videos to add more valuable information in here. If you have any suggestions or there are projects you would like me to review, just let me know in the comment section. If you like the content, hit like and subscribe, and see you in the next one. Tariq 10x.